CrossLink-NX is developed from Lattice Nexus platform. Based on the FD-SOI foundry process, the Nexus platform gives CrossLink-NX unique features and advantages when compared to other FPGAs in the same class. CrossLink-NX is up to 75% lower power, has up to 90% smaller form factor, supports instant-on performance with the fastest QSBI flash memory, has the highest memory-to-logic ratio that enhances its edge inferencing capability, has the fastest MIPI D-PHY interface, allows more aggregated sensor bandwidth into one MIPI D-PHY port. The fact that it has 100 times lower SCR let CrossLink-NX address different market segment needs. Lattice video connectivity FPGAs primarily address embedded vision applications with a focus on the MIPI D-PHY interface. Why MIPI? If you're not familiar with MIPI D-PHY, it is the most prevalent video interface connecting mobile application processors to cameras and displays. All smartphones use MIPI D-PHY interface. Embedded vision products from non-mobile market segments are choosing to design with MIPI components to leverage the economy of scale in the MIPI ecosystem. But designers will run into the following design challenges. 1. Most non-mobile segment systems don't use MIPI. They need a bridging device or completely overhaul product architecture. 2. Industrial and automotive segments are moving to higher resolution sensors and displays. The bridging device needs to be high performance and reliable. 3. Systems are supporting multiple sensors and displays. Just look at the cars today. They have multiple sensors and cameras and displays than ever before. Designers need a part with flexibility to accommodate this rapid changing requirements. Lastly, we need to apply AI at the edge to reduce latency and offload network traffic and cloud-based computation. These trends require Lattice FPGAs to address low power, small form factor, high performance, high reliability, and ease of use. CrossLink FPGAs are the right part to answer these challenges. This is a quick overview of the 3 video connectivity FPGA families. From the right-hand side, we start with CrossLink, which is the first low-power FPGA with hardened MIPI D-PHY. It supports 1.5 gigabits MIPI speed. It configures in less than 50 milliseconds. In the center, we have CrossLink Plus. CrossLink Plus has identical features as CrossLink. The biggest difference is that it has embedded flash memory to enable instant-on and fast self-configuration. It fully self-configures in less than 15 milliseconds. Lastly, CrossLink-NX upgraded on all the features from CrossLink, whether it's the number of programmable IOs, maximum D-PHY speed is now at 2.5 gigabits per second. It offers 40K and 17K logic cell versions, and it has 12 edge clocks. Its application area has expanded to include processing and video bridging. Now, let's take a closer look at CrossLink-NX. From the programmable core, FD-SOI's back-body biasing feature can change the transistor's threshold voltage, allowing the developer to pick low power and high performance modes that suit their application. High embedded memory count and DSP blocks are needed for edge AI inferencing. In addition to the fastest hardened MIPI D-PHY interface, CrossLink-NX also supports hardened one-lane Gen 2 PCI Express at 5 gigabits per second, expanding connectivity options. There are 37 differential I/O pairs, with each pair supporting up to 1.5 gigabits in a flip chip package and 1.2 gigabits per second in other packages. Other interfaces include LVDS, sub-LVDS, and SGMII. It supports DDR3 at 1066 megabits per second, and in the largest package, it supports up to 192 total I/O. Instant-on improves ease of use by providing pre-configured I/O state within 3 milliseconds, which is good for board control applications. The device, depending on the logic density, self-configures from QSBI flash memory between 8 to 14 milliseconds. This table gives you a quick by-the-number summary of CrossLink-NX features. The bigger large RAM blocks in the CrossLink-NX17 is specifically architected to store larger neural network data to enhance edge AI inferencing. We expect edge inferencing customers are more likely to choose the smaller density part to reduce power consumption. With enhanced capabilities, CrossLink-NX can expand the application use cases. More specifically, CrossLink-NX has PCI Express and SGMI to provide more ways to connect, as shown in the Edge AI Companion diagram. In the bottom left diagram, CrossLink-NX with 17K to 40K logic cells can handle image signal processing and AI inferencing in addition to interface bridging. We talk about CrossLink-NX having more edge clocks to support more sensor aggregation. Due to how the I/O is assigned to the different banks in the FPGA, it can support up to 11 sensors. That is 6 more sensors than what CrossLink can support. CrossLink-NX also supports faster DeFi at 10 gigabits per second port. The programmable differential I/O can operate up to 1.5 gigabits per second in a flip chip package, enabling higher resolution sensors and display split or duplication. This table compares the power consumption of CrossLink-NX and CrossLink in a typical reference design, using the same configuration. For this specific configuration, CrossLink-NX17 consumes only half the power of CrossLink. Even CrossLink-NX40 is better overall. This shows the power of the new Nexus platform. Thank you very much for listening.